Good morning, students. At the end of the chemical kinetics, we have already explained you how to calculate the activation energy. Anybody tell me the formula to calculate the activation energy? What is that formula? Law K2 upon K1 is equal to A upon 2.303 R T2 minus T1 divided by T1 into T2. What is T1 and T2? T1 is the initial temperature, T2 is the final temperature, right now. So on the basis of that, we have to take a question paper. That question paper is from 2018 CBSE paper, and one question is based how to calculate the activation energy. Dear students, it's very easy, and just we apply the formula. Question is, a first order reaction is 50% completed in 40 minutes at 320 Kelvin. Right now. So a first order reaction is 50% completed in 40 minutes at 300 Kelvin and 50% completed in 40 minutes. Sorry, just we have to complete the numerical. 50% completed in 40 minutes at 300 Kelvin and in 20 minutes at 320 Kelvin. Calculate activation energy of the reaction. Calculate activation energy. And in the datas, log values nowadays are given in the question paper. Log 2, you remember? Log 2 is how much here? 0.3010. Datas are given. Log 3 is equal to, what is this? This is what? It is not given. 0.40 most probably. Log 4 is given here. Log 2 and log 4. Sorry. Log 4 is given in the question paper. That is the 0.6021. R is given here 8.314 Joule, Kelvin inverse and mole inverse, and that is what the data are given in the numerical. So dear students, let you think which formula you can apply here. A first order reaction is 50% completed in 40 minutes. Time is given at 300 Kelvin and 20 minutes. Half-life is given to us at two different temperatures. Therefore, what is the first order formula? K is equal to 2.303 upon T into log of R naught upon R. What do you mean that term R naught upon R? It is the initial concentration, it is the final concentration. My dear students, if R naught and R naught given, then I have already explained you A upon A minus X. It is the first order formula, but for half-life period, tell me anybody, 0.693 upon K. It is the rate constant and time is given. You take this formula to solve this numerical. My dear students, here, see, this is the what? If I take equation 1, K is equal to 0.693 upon, what is that? T. Time is how much here? This is what? Time is 40 minutes. Right? It is the equation 1. And another log K1. So this is what? It is the K2 is equal to 0.693 upon how much minutes? 20 minutes. This is the equation. Second, just you put it in the activation energy formula here. So is it clear to you? What is that activation energy? Here log K2 upon K1 is equal to EA upon 2.303 R, you know, T2 minus T1, T1 into what is that? T2. Log K2 upon K1 is here. Divide the equation second by first. 0.693 upon 20 into, divide equation first by second. Yeah, this is what it is. The equation first is the 40, 20 upon, you can see 0.693. This is the log. 20 say 40 cancelled out. This is cancelled out here. So better to divide here. Log first, second by first. It will be better. Log second by first. K2 upon K1 equal to 0.693 upon 20 into 40 upon 0.693. Cancelled out. So this is the 2, and therefore you get the log 2. And here you get these values, log 2. Then tell me, you have to calculate what? Activation energy. So my dear students, put this formula here. So log 2 is equal to EA upon 2.303 into 8.314 into, what is that? Final temperature is, what is that? 320 Kelvin, and initial temperature was at 300 Kelvin, divided by 321 into T2, that is the 300 into 320 Kelvin. The way what you have to calculate, you can put the value of log 2, 0.3010 equal to EA upon, every parameter is given to you, this is given to you, you can calculate what energy? Activation energy in joule. And if you want to calculate in kilojoule, then you divide it by 1000, it becomes, what is that? Kilojoule. I hope it's very easy question, so far as put in the last year paper. Is it clear to you? Just to think over it. Now from the same question paper, I just give you the another question from the 2018 CBSE paper. Is the question is, for the reaction given 2N2O5 that gives this, the rate of formation of NO2 is this one, calculate the rate of disappearance of N2O5. Dear students, just to put down the question first and let me see who can solve the paper. Okay. So, dear, question is, for this reaction, N2O5, 2 times, that gives N2O4 2 times plus what is that? O2. That is given. And the rate of formation of NO2 is, the rate of formation of NO2 is 2.8 into 10 की power minus 3 mole per liter. Calculate the rate of disappearance of, calculate the rate of disappearance of, what is this? N2O5. Rate of disappearance of N2O5. My dear students, rate of reactant always in the negative sign and product always in the positive signs, because I have already explained the day one when I started chemical kinetics. I have explained very much that the reactants disappear हो जाता है and product form हो जाता है. Therefore, by convention, reactants are taken as negative and products are taken as positive. So the reaction is this one and this one. So 2N2O5 as per the question in the gaseous state undergo decomposition to form N2O4, okay, plus what is that? O2 gas. So rate is expressed as -1/2 delta N2O5 gas upon, what is that? Delta T equal to plus 1 by 2, what is that? N2O4 gas plus delta O2 gas upon what is that? Delta T. My dear students, just to go through the paper. So the formation of NO2 is, this is what? 4 times NO2. Okay, just a minute. It is the question is 4 times NO2. 4 times NO2. So here you change it 4 times NO2. Here again change 4 times NO2. Right? So 4 times means what is that? Plus 1 by 4. Right? Because of 2 and 2 of 5, 4 times NO2 plus O2. So dear students, rate of disappearance of what is this? Rate of disappearance. Calculate the rate of disappearance of N2O5. So this is the disappearance or NO2 is the appearance. Products appearance and reactant disappearance. Therefore, as such, minus 1 by 2 into delta N2O5 disappearance upon delta T is equal to plus 1 by 4 into what is the value of NO2? This value is given 2.8 into 10 to the power minus 3 mole liter minus 1. 2 and 2 cancelled out. Therefore, minus delta N2O5 upon delta T equal to, this is what actually cancelled out, 1.4 into 10 to the power minus 3 mole liter. This is what 2.8 into 10 to the power minus 3 mole per second. That is what it is the mole per second. Sorry, not mole per second. Mole per second is the answer. So 1.4, that is what? NO2 here. So this is a very easy question. The way you can solve it. And then I give you the other year's paper. This is the CBSE paper, and that is from the session 2017 paper. And the question, in addition to the difference between order and molecularity of the reaction, numerical is given that. Like, so is it clear to everyone? It's all right. May we proceed further? Okay. Just to write down the question. 2017 paper, right? A first order reaction takes 20 minutes for 25% decomposition. Calculate the time when, calculate the time when 75% of the reaction completed. My dear students, again the data is given. So therefore, find the log is no longer a problem. CBSE has already introduced the already values given in the data given in the paper. So my dear students, again you know data is given log 2 0.3010, log here 3 0.4771, and log 4 is equal to 0.6021. and log 5 0.7990. So these values are given. So tell me anybody, how can you solve? First you see the first order reaction. Right now, first order reaction takes 20 minutes for 25% decomposition. Calculate the time when 75% of the reaction completed. So let you make two equations right now and let you compare equation first and second. So from the data, first order reaction K is equal to what? 2.303 upon T into log of A upon A minus X. Since it is the 25% decomposed, let you take initial concentration what? 100%. So just we apply K is equal to 2.303 upon 20 into log of 100 upon 100 minus 25. 100 minus 25, that becomes 100 upon what is that? 75. 4 times or 3 times log 4 by 3. Distance here. From the another case here, take the equation 1. So far as K is equal to 2.303 upon time we have not given. For the second case, calculate the time. What you have to calculate? Time you have to calculate. So tell me, 2.303 upon T into log of 75%. 100 upon 100 minus 75. That means 100 upon what? 25. That becomes what is that? Log 4. This is the equation what? Second. Log K, log K cancelled out. Let to divide first and second. Compare first and second. We get the right answer. 2 cancel out. This is what? And you take these values and the way you can solve the question. That is very easy. Compare equation first and second. KK cancelled out. 20 and time is to be calculated here. And this data we got it. This data we got it. So this is all about. Go through this chapter. This is the numerical oriented chapter and highly conceptual. And I hope you people will be able to solve every kind of questions. Thank you very much. Have a nice day. God bless you.